Hi everybody, hope that you're doing well and that we're ready to move forward. We started off the 8.2 section by solving quadratic equations by the quadratic formula. And now the final stage of 8.2 is to take a look at two minor sort of like sub-objectives. The first of the two objectives is to define and to be able to find what's referred to as the discriminant. And the second item will be to be able to take solutions of a quadratic equation and be able to write the quadratic equation. And so let's begin today in this second video of 8.2 with the concept of the discriminant. Okay? Now here's what we mean by the discriminant. This discriminant is one key little item that is a part of the quadratic formula. The definition of the discriminant is it determines the number and the type of solutions that the quadratic equation has. Just repeating it again. The purpose of the discriminant is to determine the number and the type of solutions the quadratic equation has. Now I mentioned that one key part of the quadratic formula is defined to be the discriminant. And that is what I have somewhat boxed off here. The discriminant is equal to the binomial expression b squared minus 4ac that is found underneath the radical sign. The radicand, we can say. The discriminant is simply this binomial, not the radical of this, but simply b squared minus 4ac. We want to go through the different types of situations we have when we are finding the discriminant from some given quadratic equation. There's three situations involved, and we want to define those three situations, and then we'll take a look at some examples. Situation number one. If the value of b squared minus 4ac is greater than 0, that indicates that there will be two real number solutions. Two unequal real number solutions. Now, within this category, we want to define two specialized cases when the value of the discriminant is greater than 0. Case number one. If that number, the value of the discriminant, is a perfect square, greater than 0, like 4, 9, 1, 16, 25, 36, etc. If the value of the discriminant, being greater than 0, is a perfect square, that will indicate there will be two real rational solutions, or just simply two rational solutions. If the value of the discriminant, being greater than 0, happens to not be a perfect square, 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, etc., etc. It's not a perfect square, but it's greater than 0. There will be two real number solutions, but specifically, there will be two irrational conjugate solutions. So we have to spend a little bit of time on the notes and just sort of memorize these different conditions that are set forth. Let me just repeat it. If the number, the value of the discriminant, is greater than 0, and it is a perfect square, there will be two rational number solutions. If the value of the discriminant being greater than 0 is not a perfect square, there will be two irrational conjugate solutions. Condition number 2. If the value of the discriminant is equal to 0, not less than, not greater than, but equal to 0, there will be one real rational solution. It's actually a double root solution. It's the same solution that appears twice. So we ordinarily just say that there is one real rational solution. And situation number 3. If the value of b squared minus 4ac is less than 0, that will indicate that there will be two imaginary solutions. In other words, the symbol of I is going to be involved in our solution. There will be complex conjugate solutions if the value of the discriminant is less than 0. Two imaginary solutions, and the solutions will be complex conjugates of one another. Now, how do we test you on this? Well, we're going to come to the board, and we're going to go through 3 different quadratic equations. And the purpose of these quadratic equations is not to solve them, but to identify the value of the discriminant. That's why I wrote that key binomial expression right here. We're going to be substituting into this in a moment, but we can't substitute until we identify the values of A, B, and C. And the first thing that you have to make sure that you're doing when you're looking at the quadratic equation, you need to make sure that it's written in standard form. Because until it's written in standard form, you do not identify your A, your B, or your C. Number 1, he's ready to go. He's in standard form. So let's identify. A is the coefficient of the quadratic term. That would be 1. B, that would be the coefficient of the linear term. That would be positive 6. And C, that would be the constant coefficient. That would be positive 9. Now, let's go through and let's identify the discriminant for problem number 1. B, 6. We'll tuck it. It's got to be squared. Bring down the negative 4, and I'm going to make 2 houses. In the first house, we'll put the value of A, 1. And in the second, the value of C, 9. Come down. Let's follow the order of operations. Let's take care of this power. Bring down the negative sign because there's only one negative sign in this little grouping that we're going to multiply together. 4 times 1 is 4, and 4 times 9 is 36. 36 minus 36, there is the value of the discriminant. Now, the question is going to ask this. Twofold. Find the value of the discriminant and then identify the number and the type of solutions that value is going to represent. Since the value of the discriminant is 0, I'll replay back to that chart just a little bit. If the value of the discriminant is 0, there is exactly one real rational solution. And that is what you write. One real rational solution. If you leave out the word real, that is not an issue, because a rational number is a real number. So specifically, it's one double-rooted, one double solution rational number that's going to be the solution of that given equation. But we specifically say that it's one rational solution. That's number 1. So we'll have to memorize those conditions. Let's go to number 2. Number 2 is not ready. We need to move the 5 over to the other side, and we'll have to change its sign. So we'll have 2x squared, negative 7x. Move him over and change his sign. Negative 5 is equal to 0. A is equal to 2. B is equal to negative 7. C is equal to negative 5. Let's plug those values in. The value of B is negative 7. Negative 7 squared. Bring down the negative 4. A couple of little houses. A, 2. C, negative 5. Negative 7 squared is 49. Negative times positive times negative. There's an even number of negative factors. That's going to promote a positive sign. 4 times 2 is 8, times 5, 40. Add them up. 89 is the value of the discriminant. If the value of the discriminant is greater than 0, and it is not a perfect square, and 89 is not a perfect square, that indicates that there will be 2 irrational conjugates. Example, I'm just calling out a pair. 2 irrational conjugates. Negative 2 root 7. Positive 2 root 7. Those would be irrational conjugates. That's exactly what this equation is going to have when we find its discriminant. One last one. Number 3. The 2x has to move over. The negative 4 has to move over. Let's move them. 3x squared. Change sign. Negative 2x. Change sign. Positive 4 is equal to 0. A is 3. B, negative 2. C, positive 4. Let's substitute. B is negative 2. There's square B. Bring down that negative 4. A couple of houses. The value of A is 3. The value of C is 4. Negative 2 squared. Positive 4. There's only one negative sign amongst those 3 factors. Negative. 4 times 3 is 12. 12 times 4, a negative 48. Add that positive 4 with that negative 48. The discriminant is negative 44. The discriminant is not greater than 0. It's not equal to 0. It's less than 0. And if the discriminant is negative, that's going to indicate 2 imaginary solutions. And specifically when we write it, we'll ordinarily write 2 complex conjugates. If you want to, in addition to this, write down 2 imaginary solutions, that's fine. There's no issue. Now, people, that is the discriminant. The discriminant does have some importance, and we'll realize more of its importance as we work our way through Chapter 8. Now let's go to the final little objective of 8.2, and that's being able to do this. This will be our objective. You are going to be given the solution set. You're maybe looking right down here that Kristen is showing. You're going to be looking at the solution sets of a given quadratic equation. And the objective will be to take those solutions and do a process with this objective. We want to be able to identify the quadratic equation that had those solutions. So I'm going to take us back to a situation just to kind of give us an idea of what this process is going to call for. Let's say that we begin off with this quadratic equation, x squared minus 5x plus 6 is equal to 0. Let's say we're going to solve that. Now that we've shown all of the different ways to solve a quadratic equation, we could use the quadratic formula, we could complete the square, or we could see if the trinomial on the left-hand side is able to be factored. And I've already done the work, it's able to be factored. X squared minus 5x plus 6 has these two binomial factors. You should be able to see it very easily right now that the factoring approach would be the fastest. Once we've identified our two binomial factors, we begin to use the zero product property. And we set each one of these binomial factors equal to 0. X minus 3 is equal to 0, or x minus 2 is equal to 0. And then we move the 3 over to the other side and change its sign. We move the 2 over to the other side and change its sign. And we get x is equal to 3, or x is equal to 2. And we put the solutions in the braces, and we have our roster notation solution. What is this objective going to tell us to do? They're going to give us the set whose members are 3 and 2. And they want us to derive him. They want us to take these solutions and derive the quadratic equation that afforded those solutions. We'll show you how it goes. Let's start with number 1. I'll write the roster notation. The set whose members are negative 3/5 or a positive 1/4. The first thing that we're going to do, we're going to do this process that we shared right here. We're going to do it in reverse order. We're going to identify the two values of x that gave us those. Over here. Step 1. Bring down x and let it first equal negative 3/5. Or bring down x, or bring over x, and let it also equal 1/4. What did we then do from here? We moved that 3 over to the other side, changed its sign so that we could set it equal to 0. And we did the same thing here. We moved that 2 over to the other side and set it equal to 0. Back to our problem. We moved the negative 3/5 over to the left-hand side and change its sign, because we have to set it equal to 0, and we do the same thing to this one. Bring down the x, move the 1/4 over to the left-hand side and change its sign to a negative and set it equal to 0. And now, in this particular case, because this equation contains a fraction, and so does this one, we want to get rid of those fractions. So we're going to tuck the left-hand side and tuck the right, tuck the left, tuck the right. Going back to this one, there's only one fraction that is witnessed. It's a denominator of 5. We're going to multiply both sides of this equation by 5. I'm going to stick another 5 right about here. Now here we go. 5 times x, 5x. Bring down the plus sign. 3/5 times this 5 right here. These 5s are going to cross cancel out to 1s. And that 1 times 3 is going to give us a positive 3. 5 times 0 is 0. Now we've got it down to somewhat of a binomial that we want here. Or, same thing here. We want to get rid of that fraction. We're going to multiply both sides by the common denominator of 4. One time. A second time. A third time. Let's distribute. 4x minus, the 4's will cancel out to 1's. 4x minus 1 is equal to 0. Now, we take each of these two binomials, the 5x plus 3, along with the 4x minus 1. If you want to know where I'm at, I'm right here. I'm basically, I want to get to this point right here. That's where I want to get. So we're going to tuck this 5x plus 3. And right beside it, we're going to tuck the 4x minus 1. And both of them are going to be set equal to 0. And now the final step that we do is FOIL those two binomials. First terms, 20x squared. Now I'm going to kind of dual up when I do the outer and the inner. There's a negative 5x. The inner, a positive 12x. A negative 5x combined with a 12x would be a positive 7x. Then the last terms, negative 3 is equal to 0. There's the quadratic equation. If we were to solve this quadratic equation, those will be our solutions. So it's a bit of a process. And what made this one just a little bit different, when we moved these two solutions back over to the left-hand side, we had rational numbers here and there, and we needed to get rid of those. We don't want our two binomial factors to contain fractions. So we got rid of them. All right. Let's quickly go to the second one. Show you the process. Number 2. The set whose members are 5 root 2, negative 5 root 2. Conjugates, irrational conjugates. We begin by letting x be equal to the first solution, or x is equal to the second solution. Next, move the 5 root 2 over to the left-hand side to join it with the x, and likewise here, because we've got to get it set equal to 0. So when we move him over to the left, we'll change his sign. X minus 5 root 2 is equal to 0, or x, move him over, change his sign, plus 5 root 2 is equal to 0. We don't have any fractions involved. This is a binomial. This is a binomial. We will now enclose each one of them. X minus 5 root 2 multiplied by the quantity of x plus 5 root 2, and they will be equal to 0. And now we FOIL. And when we FOIL, it isn't necessary to do the outer and the inner products, because these two are conjugates. They're the same terms, they only differ in the signs between them. So all we have to do is multiply the first terms and the last terms, and we ought to have our quadratic equation. So let's multiply the first terms and we'd have x squared. You see, if you did do the outer, you'd have a positive 5x root 2, and the inner, you'd have a negative 5x root 2, and they'd cancel. Multiply the last. Negative 5 root 2 times a positive 5 root 2, that would give us negative 25 root 4. And that would be equal to 0. Now let's simplify. X squared minus 25 times 2 is equal to 0, and we would have this: x squared minus 50 is equal to 0, and there would be the quadratic equation, whose solutions would be those irrational conjugates that we see up there. 3 times the charm, maybe. Let's do the third and final one. It's the set whose members are negative 7i and its conjugate, positive 7i. 2 imaginary solutions, 2 complex conjugates. That would indicate that the value of the discriminant would have to be less than 0. That's really not something that we're interested in right now, but that's what would happen. We want the quadratic equation. Let x be equal to the first solution, or let x be equal to its conjugate, 7i. Next, move the negative 7i over to the left, move the 7i over to the left, change its sign. X plus 7i is equal to 0, or x negative 7i is equal to 0. Binomial. Binomial. Form the product of those 2 binomials and set it equal to 0. X plus 7i, x minus 7i. People, they're conjugates. Don't have to do the outer and the inner, just the first and the last. The first, x squared. The last, negative 49i squared is equal to 0. Simplify. It's not going to stay that way because we know that I squared is equivalent to the real number negative 1. X squared negative 49 multiplied by negative 1 is equal to 0. X squared, negative times negative, positive 49 is equal to 0. There's the quadratic equation. Done. Now that puts a close on 8.2. We'll move into 8.3 and we'll get into graphing a quadratic function. And that's where we will get accustomed to the parabola and all of the vocabulary that is surrounding that. I can't wait. Okay, and I hope you'll be ready for it when we move into 8.3. You take care of yourself and have a good day. Bye-bye.